In this video, we look at problem solving with combinations. So as a first example here, let's assume that you're going to visit a pizza shop, and that pizza shop only has 5 choices for toppings. We'll also assume that you can choose a pizza with 0 toppings. It's not always the case. Some pizza places would include cheese as a topping or sauce as a topping. We'll assume that at this pizza place, you are able to get 0 toppings. So what this question is really asking is how many different pizzas could we possibly get? So we can get a pizza with 0 toppings. We can get a whole bunch of different pizzas with 1 topping, a whole bunch of different pizzas with 2 toppings, and so on. The question's asking how many different pizzas could we possibly order. So in this case, we'll start, and let's say we want to choose 0 toppings for our pizza. So we could choose a pizza with 0 toppings. There are 5 toppings to choose from, and we want 0 toppings. So that's a total of 5. Choose 0 different ways to do that. We could also choose a pizza with 1 topping. So our pizza could have 1 topping. There are 5 choose 1 ways to do that. It could have 2 toppings. 5 choose 2 ways to do that. 3 toppings is 5 choose 3. 4 toppings would be 5 choose 4. And 5 toppings would be 5 choose 5. Now, we're not getting a pizza with 0 toppings and a pizza with 1 topping and a pizza with 2 toppings. We're getting one of these pizzas. So in this case, it's the 0 topping pizza or a 1 topping pizza or a 2 topping pizza or a 3 topping pizza, and so on. So because it's one or the other, we just add these two things together. So this is for the number of ways to get a 0 topping or a 1 topping pizza. If we want to also include a 2 topping pizza, so the number of ways to get a 0 topping or 1 topping or 2 topping, and I think you get the idea here. We just go through and add all of these different ways for this to happen. So now we can go through and we can use the choose button on our calculator. It probably looks something like this, NCR. It may look something like this, CN, R. Whole bunch of different possibilities there, and sometimes it's hidden underneath a probability menu, so PRB, and finding it under there. So if we go to our calculators now and evaluate 5 choose 0, well, there's one way to choose 0 items from 5, 5 ways to choose 1 item from 5, 10 ways for 5 choose 2, 10 ways for 5 choose 3, 5 ways for 5 choose 4, and 1 way to do 5 choose 5. We add that all up and we get a total of 32, which means that there are 32 possible ways we can make a pizza from this pizza place that offers only 5 toppings. So that's one way to do this question. I think it makes a lot of sense in terms of what's going on. The other way to do this question is to look at the 5 toppings. Here we are, 1 topping, 2 topping, 3 topping, 4 topping, and 5 toppings. We can give these toppings names if we want. You know, if this is our pepperoni, and this is our I don't know, mushrooms, our cheese, bacon, and maybe anchovies. So for each one of the toppings, we really have 2 choices to make. We can include that selection in our pizza or not. So I have 2 choices for pepperoni. I either have pepperoni or I don't have pepperoni. That's where this 2 comes from. There are 2 choices here. There are 2 choices for the next topping, the mushroom, and 2 choices for the cheese. Include it or don't include it. Include it or don't include it. And include it or don't include it. So now we for each topping we have 2 options, and we're doing those 2 options. So we're doing the pepperoni choice and the mushroom choice and the cheese choice and the bacon choice and the anchovy choice. So because we're doing all of those choices, we end up multiplying these 2's together, and we get a final answer. 2 times 2 times 2 times 2 is equal to 32. So there are 32 different ways that we can make that selection. And it's maybe worth noting here that 32 is 2 to the exponent 5. I say that now because that's actually some useful information that we'll come back to a little bit later on. So this is useful. Why is it useful? Well, we had 5 toppings. And a shortcut here would be to do this. We'll come back to this idea a little bit later on. And then the other idea that's worth noting is the pattern of numbers in this list right here. Notice the pattern of numbers here. We'll talk a little bit more about that later on. So that's not super critical for today. 2 ways to do this problem. Doesn't matter which way you choose, whatever way is most comfortable for you, and whatever you understand the most. To summarize kind of what we just did here, the total number of choices you can make from n distinct objects. So from n distinct objects. And again, order is not important. So if the order is not important, we're talking about a combination, is 2 to the n. So same idea. I mean, that ties in to what we talked about up here. If there are 5 choices, the total number of ways that we can do this is 2 to the 5. Now, don't forget, this includes the set where there are no items selected. So this 32 included choosing no pepperoni, no meat, no cheese, no bacon, no, I almost said avocado, but I think that was anchovies, what we said. So it's important to remember that, because in some cases you will have to make a selection. So if your pizza, if your pizza place says that if you're going to order a pizza with no toppings, that's not a pizza, that's a flatbread, and you're asked how many pizzas you can make, then you would have to subtract that one set of pizzas that has absolutely nothing on it. And that's what this little bit down here says. It says if a selection must be made, so if you have to make a selection, there's one fewer. We take out the set that had nothing in it. So in the example here, this 5 choose 0. Let me this 5 choose 0 up here. This was the example where we had no toppings. So if we have to make a selection, then we have to subtract that one, in which case there would only be 31 toppings instead of 32. Again, it depends on how the question's worded and what it is that you're trying to find. All right, let's move on to something a little bit different. Not totally different, but a little different. Move on to combinations with identical items. So here we have an example where you have a jar with 3 red candies, 3 reds, 2 blues, and 4 greens. Question here is how many ways could you reach in? So if your candies, you can't tell them apart, they all look the same. That's where the identical items part comes in. Candies are all the same. So you have 3, of one kind of red candy that all look the same, 2 of one kind that are blue that all look the same, and 4 green. The question is how many ways could you reach in? And again, we'll do this a couple of different ways, just so you can get a sense of what's going on here. So I'm going to list here what are the possibilities for choosing a red candy. So for a red candy, if we reach in and grab some candies, and that's kind of a key word here, some. It doesn't tell us how many, so we have to assume that means we have the choice of how many candies. So if I reach in and grab candies, I could reach in and grab 0 red ones, I could grab 1 red one, I could grab 2 red ones, or I could grab 3 red ones. I can't grab any more than 3 because remember there were only 3 red candies to start with. So that's for the red. We can do the same thing for the blue. And we're going to reach in for 2 blue candies. Well, we could get 0 of them, we could get 1 of them, or we could get 2 blue candies. And lastly, for the greens, same idea, 0, 1, 2, 3, or 4 candies. So if we look at this, we have 4 different options for getting a red candy. So here are the number of ways that we could get a red candy. 1, 2, 3, or 4. We have 3 different options for getting blue candies, and we have 5 different options for getting green candies. 1, 2, 3, 4, and 5. So when we reach in, we're getting, we're able to make a selection for some red, some blue, and some green. So in this case, the total number of candies that we can grab, or the number of ways to choose a candy, so number of ways is equal to 4 times 3 times 5. But don't forget, this includes the selection that we made where we have 0 red, 0 blue, and 0 green. Well, if we got we reached in and we grabbed 0 red, 0 blue, and 0 green in our hand, then we actually haven't made a selection. So it's important to realize that in this case, we need to take away that empty set that has just no candies in it. So that's what this is. This is the no candies. We reach in and we have nothing. So this is 0 red, 0 blue, and 0 green. And so if we continue on here, 4 times 3 times 5, 4 times 3 is 12, times 5 is 60, and then we're going to subtract the 1, and we get 59 choices. So therefore, we can make 59 selections. And if you wanted to, you could make a tree diagram and list all of those possibilities. It obviously, with 59 branches, it gets a little bit out of hand, but it's certainly one option. The other option is to do the same way that we did the previous problem and look at, well, all of the different cases. Case 1, we get 0 red, 1 blue, and 0 green kind of thing, and going through all of the different possibilities is very time consuming to do that. So this method here that I've shown you is a quicker way to do that. At the bottom of the page here is basically a summary here. If we have the total number of selections, if we have P items of one kind, Q of another, and R of another, and so on, is just P plus 1 times Q plus 1 plus R times 1 minus 1. Again, that minus 1 is to eliminate the set where there is no selection. So this would be no P's, Q's, R's, etc. So we take away that empty set that has nothing in it. All right, let's move right along. Let's change the question a little bit with the candies. So again, still using those same candies, the 3 red, 2 blue, and 3 green. So we'll just keep those numbers in mind. The question is asking us, how many ways can you choose 5 candies if the selection is to include some red candies, pardon me. So we're going to choose some, we're going to make sure that we have some red candies. I'm going to do this 2 different ways. Our first method is going to be fairly straightforward, I think. So we're going to look at a whole bunch of different cases. We want to include some red candies. Well, let's look at the different cases. Let's look at if we choose 1 red candy. Well, how many red candies are there? There are 3 red candies, and we want to choose one of them. So there are 3 choose one ways to get a red candy. Now we're choosing 5 candies in total. 5 candies in total. We've already chosen 1 red candy. How many candies are left to choose? Well, if we've chose 1 already and we're going to choose 5, we need to choose 4 more. And those 4 more need to come from candies that aren't red, because we only want 1 red candy, and we've already got it here. Well, if you look up here, the candies that aren't red are these ones right here. We have 2 blue and 4 green candies that aren't red. Total of 6 candies that aren't red, and we want 4 of them. Okay, so that's 1 red candy. The other option is we can have 2 red candies. So this is looking a lot like the pizza example where we have 1 option or another option and so on. So there are 3 red candies. We want 2 of them. We've already chosen 2 candies. We want a total of 5. So we need to choose 3 more from the candies that aren't red. Well, the candies that aren't red are still these 6 blue and green candies, yeah. So there are 6 choose 3 ways to do that. And then the last option is that we could have 3 choose 3 red candies, so we could get 3 red candies. Again, we're choosing a total of 5 candies. If we have 3 reds, we need to choose 2 more, and we need to choose them from the candies that aren't red, which are 6 different candies. And again, we're doing the one situation, the one scenario, this one scenario, or this one scenario, or this other scenario. So because it's a situation where it's one or the other, we're going to end up adding these things together. So we can go to our calculators and do 3 choose 1 times 6 choose 4. That'll give us a total of 45. 3 choose 2 and 6 choose 3 is 60. And 3 choose 3 times 6 choose 2 is 15. And we add those all up, and we get 120. Now this problem wasn't so bad to do this method because we only had 3 different possibilities to look at. But if I change the numbers a little bit, and let's say we had 12 red candies instead of just 3 red candies, this method becomes very, very tedious. So instead, what we can do is we can do something called the indirect method. And what the indirect method says is that we can find all of the combinations with no restrictions. So how many ways can we choose those 5 candies that we're supposed to be finding, those 5 candies? How many ways can we find those? And then we subtract all the ones that don't have any red candies in them. So let's try to do it the indirect method just so that you have a comparison. So this is our second method here. So you have a comparison. Method 2, it's the indirect method. So we're going to look at the total number of candies. Well, how many candies are there in total? There are 4 plus 2, which is 6, plus 3 more is 9. So the total number of choices we could make is 9, and we're choosing 5 of them. So 9 choose 5 is the total number of possibilities for us. Then we want to subtract the ones that don't have any red candies. Well, if we take out the red candies from this list of 9 candies, we only have 6 candies left. So the ones without red candies, let's take out the red, strike out the red. Let's just do this, and we won't even realize it's there. There are only 6 candies left, and we need to choose 5 of them because there aren't any red candies to choose from. So we're going to subtract 6 choose 5. So just maybe it's worth noting here, this is the total number of candies. Total number of selections, pardon me. Total number of selections. And these are the selections with no red candies. Selections without red. And then we can finish this up. And again, just go to our calculators. 9 choose 5 is 126. 6 choose 5 is 6. And we get an answer of 120. Same answer that we had above. Same answers here. 2 different ways. The indirect method sometimes is a little bit faster. In this example, it's probably not that much work to do the direct method, but there will be instances where the direct method is very time consuming. So therefore, let's try that again. Therefore, there are 120 possible selections. All right, and that's some background information, a few different examples about how we can solve problems with combinations.